All right. Hey, guys and gals. Hello, 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 guys and gals. Turn it up. Excuse me. Gotta get the old stream chatting voice going again. Let's go. Let's go, guys and gals. Thank you for dropping by. Thank you for hitting that play button. Turn it up. Turn it up. You know I appreciate that. I love it when you do. I love it when you do. Let's go. It's Fun Day Monday. Exciting. Hopefully the stream kind of flows smoothly. That's all I can hope for. That's all I can hope for. Okay. All right, here we are. Allow me to, guys and gals, finish with the mod stuff so I can get it done and out of the way. Lurkers and twerkers, appreciate you dropping by. Let's go. Much love. Much love. You guys make my day when you show up. You truly do. Yes, you do. Okay. Just finishing up. Bear with me, guys. Have some patience. Give me a couple of minutes. Allow me a couple of minutes. And, yeah, if you need something quick to drink or something, quick latrine break, whatever you need, by all means. It's great to have you. It always is. You know it is. It's always good to have you. All right. Yeah, there we go. Almost done. Getting close. Want to get the mod stuff just out of the way. Do a bit of spam chatting, you know, stuff for you guys and gals to read while you're lurking and twerking. Keep you motivated as well. That's kind of the goal. Keep you motivated. Some motivational quotes. Da, da, da. There we go. Okay. All right. All right. There we go. Okay. Let's close this. Be gone. Well, I don't mean to be mean to WordPad. I love WordPad. WordPad, I love you. I still have it. Microsoft, joke's on you. Ha 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 ha. Oh, yeah. If most of you don't know, they actually discontinued it with one of their updates. Bum, bum, bum. I meant to say right before that, but I still have it. Let's go. Let's go. All right. Trying to shorten my intros. I know they get a little lengthy, but you know, kind of allowing you guys and gals to kind of drop by, settle in, do your thing, give people time to kind of, you know, chat a little bit, pump you up, get you excited to learn some C++ coding because it's fun. It is fun. It is not for all, but it is for you. Let's go. Let's go. I like that. I'm gonna have to try to keep that. I don't know how I'm gonna keep that. I know you probably can't see this on the screen because of my, yeah, you can see it good. All right, let's go. I'm happy about that. I like the memes. They're funny. They are. Memes are funny. Especially the gooders. The gooder oneers. And I said that deliberately to brutalize the English language. Because I'm a mathematician, I could do more than arranging 26 letters of the alphabet to make wordies and calling it a flex. Math genius. I'm smarter than you. I can make words. One more time. That's a little bit of a dig in case you didn't get it. But yeah. Math. Numbers are infinite. Numbers are infinite. Okay. That is enough. Much love to every single one of you. Lurkers and twerkers. Sandwich making workers. You know I love you guys. You know I do. I'm always saying it. Always. I appreciate you. Johnny with Bologna&Weiners coding. Let's go. I did change the channel name. It's great. I love it. Some of you love it too. Literally. The struggles of being an indie dev. I can and I must continue. All right, it's great to have you guys and gals. Thank you for learning along. Just because my situation's my situation doesn't mean it's also yours, okay? Maybe you have better luck than I do. I do wish you all the best on your endeavor and your dreams, your coding journey. I wish you all the best, success, and all those things. Again, for myself, I don't know. These are just my thoughts. Other people have other opinions and thoughts, as you know. But I feel if you learn C++ first, any other language is just going to be like so easy to learn. That's what I'm thinking. I went right into C sharp. It's like, yeah. It's only it's only the syntax is different. But anyways, that's what I think. In regards to, if you want to work for a company and such, hopefully everything's good on the stream here. Yeah, my mic's going good on Streamlabs, but I should check the live stream. I have to kind of get my thoughts here again. Hopefully everything... Okay, perfect. Good. I just need to check to confirm. Sometimes Streamlabs, I have to constantly check settings before I start streaming, because somehow they magically just, disable themselves magically on their own. I don't know how this stuff magically happens, but it does. So gotta constantly check, make sure we're good. So yeah, but if you plan on working for a business or company, myself, I recommend doing the hardest thing first. I'm not going to say it's the hardest. I don't want to say that. It's probably the most challenging and the most difficult for most, maybe not most people, a lot of people, learning C++. You have to desire it and you have to want it, right? You have to keep yourself motivated, right? I try to do my best to keep you motivated. I do, but I'm not there all the time, right? So I try. I support you. I 100% support you in your endeavor in learning this. My other point is if you do want to work for a company, you do have to learn the other languages. Some companies, they want a whole list of things for you to know before they even consider hiring you. It's crazy. It's really insane. The expectations they have for beginner coders. It's pretty high. Right? SQL, Python, there's another, couple of things. I could research. I've looked at different jobs and that, all the different things and qualifications. They want you to understand databases and Excel. Of course, you can make sure you know how to use Excel and I don't know what else I do. I don't work for a company, so I do my own thing. Right? I don't know. For me, I'm not into politics and stuff. I'm a bit of a recluse, a bit of a loner. So it's like, what I mean is, I'm the type of guy I don't need people around me to help me. Like I got this. It's kind of like, hold my beer, get the F out of here, leave me alone. I've got this. Right? I don't need my hand held. I figure things out on my own. Okay? I will reach out and ask questions if I need to, right? I'm not 100%, donkey. Right? But I can be a team player, but I don't really work in a team environment very much, so I'm a solo kind of guy. There's a lot of us out there that are like this. We're doers. We're doers, okay? We don't need to go beep boop beep boop beep boop 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 beep boop boop. Cousin, how do you do this? We're not perfect. We are going to have stumbling blocks. We are going to make mistakes because we still are human, right? A lot of times I need to kind of just sit and just think things through. You know, for the most part, I could figure it out 5-10 minutes. Okay, I wouldn't be one of those that wastes a whole day of my employer's wages and income trying to solve a problem. Okay, definitely not. I will admit, though, when I'm kind of doing stuff live stream, you know, when I come across like little silliness things, I'm not 100% focused on the task, right? Whereas if I'm just doing my own thing and figuring things out, a lot of times I'll talk out loud, right? When I'm doing coding and stuff, that helps. Like, people might think you're crazy and stuff, but talking out loud like helps. It's huge. But doing stuff live and that, and it's like, man, trying to figure, you know, you're thinking and you got things going on, lots of tabs open up in the head or in the brain, and you're trying to figure things out on the fly. It's a little more challenging when you're doing it live, right? I won't lie. Recently I did a whole class in that, with the draw a rectangle. A lot of you probably seen that. It's going to be up on YouTube. I did fix the code. I had to push through. I persevered. It's kind of like one of them George Costanza moments. You're driving home from work and you're like, that's what I should have said. And you turn the car around, you start heading back. You probably know that scene. I believe it was the episode of where the guy says to George, "Hey George, the ocean called, they're out of shrimp," or something to that effect. It's pretty good, because he was savaging those shrimp. I love humor. It's fun. Funny. All right, I think that's enough of that. I've just finished saying I'm gonna try to keep my intro shorter. Oh my god, sorry guys. I just can't. I don't know what's wrong with me. I'm sorry. All right. We better get into this. Anyways, I'm trying to support you guys here, chat with you a little bit, keep you entertained, you know, make it, you know, mix it up with, you know, a little bit of chat and, you know, getting into some coding, right? Trying to make it a little more interesting, you know, because again, bottom line, if this is something you want to do, you have to want it. You have to want it, right? You have to desire it, and you have to put in the time. You do. You have to put in the grind. You have to just grind and practice. Make mistakes. Make all the mistakes you want. I'm not judging you. I don't care. That's how you get better. Okay? Forget what the other guy thinks, because he's a... Yee-haw! Yee-haw! So yeah, lurkers and twerkers, sandwich making workers, followers, supporters of the channel. Johnny with Bologna&Weiners Coding. I like it now, I'm rolling with it. Formerly known as WhiskeyTango Sharp. Let's go, guys. Appreciate you. Let's get into doing some coding. It's time to throw on the old thinking cap. Leave the dunce cappers with the dunce cappers that think they're smart cappers, but they're really dunce cappers. You know what I mean? Jelly bean. Let's do some coding, because it's fun. It's fun. Fun for me! Again, you don't have to be a math major to do this kind of stuff. You don't. Anybody can learn this stuff. I guess, I don't know. I have a logical mind, so mathematics was easy for me. All right. Time to turn it up. We are continuing with, okay. I was thinking, well, we've been working on referencing and dereferencing and memory addresses and how to access all that. I think I gave, like, the first video I thought went really well. The second video, I might have been a little, I don't know. Was I too harsh, guys? I don't know. I apologize if I was, just trying to get the point across, Okay? Sometimes a little tough love doesn't hurt, right? What doesn't kill you will make you stronger. It's facts. Okay. Let's see. Do use the indirection operator to access the data stored at the address in a pointer, right? That's the one for dereferencing, right? If you're passing in a memory address, you got to dereference it. Basically, you're taking the memory address. You can kind of look at it like that. You're taking the memory address and turning it into the value that's stored there, really. And it's not exactly like that, but however you want to logically look at it, right? You're accessing the data that's stored at that location in essence, okay? Do initialize all pointers either to a valid address or to a null. Let's bring up the program. Okay, do we still have code there? Right. This is the statement I just made right here. Okay? Always do that. Initialization, right? We kind of went over that lots. If you're following the series, guys and gals, again, quickly, those of you that are just dropping by, checking out the content for the first time, it's great to have you. I absolutely love it when you show up, right? If you're dropping by and you're watching the content and you're clicking and playing all those things, that automatically tells me you're an inquisitive, learning type individual, okay, that likes to learn. I love you kind of people. I do. Right? And, I mean, you can learn whatever you want to learn. I don't care. Just learn something. It doesn't have to be this, but by all means, come and learn this. Come drop by and learn and join. It's great to have you. Again, I export all my videos over to YouTube land. Unfortunately, fortunately, however you want to look at it. I can't have all of my videos on Twitch as much as I would love to. I have a short time frame for storing videos. Okay, so therefore equals, I have to export them over onto YouTube so that I can keep the content for you guys to learn. And, I mean, that's the only thing I can really do. Unless I can download them to my PC, I guess, but what's that going to do? How's that going to help you? So over on YouTube land, Bologna&Weiners coding. Because, yeah, that's life. That's real life here. It's not always like that, but it feels like it. Anyways, I'll tell you, we're not eating beef Wellington over here, guys. I'll tell you that much. I mean, this dream endeavor, if you work for a company or whatever, technically speaking, you can make $100K a year doing this kind of stuff, right? You just got to get good. You got to put in the time. You got to put in the grind, okay? All right, put milk in your cornflakes and stop dropping tears in it. Let's go. that's my warrior mentality, supportive advice. Let's go. All right, so yeah, if you want to learn, start from the bottom. That's what I recommend. Step one, or the first step, we're going step by step here, gradually, in a linear fashion, right? Along the hypotenuse of a right triangle. That's what we're doing. I'm helping you guys learn and grow with examples and explaining, and hopefully not over explaining. I do talk a lot. I know we need to get into learning here, but I gotta say this all the time, just, for those that are kind of new and dropping by. Content's there. If you want to learn, I recommend gradually starting from the beginning, growing with us, all of us learning and working, doing the series together, lecture. This is a class/lecture, okay? That's what this is. Just to be clear. Okay? This isn't a 5-minute video on how to write a variable name. Ain't I awesome? I know. So yeah, no, it's great to have you. It's great to have you. It truly is. If you could kind of deal with my wittiness, sarcasm, and all those things, and you are one solid individual. You truly are. You are a solid person. I love it. So yeah, and then if you get to this point, this video again, it'll be one of those situations again. Oh wow, hey man, it's great to see you again. Man, it's so guy, girl, whoever you are, because I can't see you obviously. But it's great to have you, man. Glad you're back. We're all playing golf together. We're all, it's a par course, but who cares? We're having fun. Let's go. All right, using pointers. To declare a pointer, write the type of the variable or object whose address will be stored in the pointer, followed by the pointer, which is the asterisk. Asterisk! I don't know why I can't say that word, guys. Asterisk. You know what I mean? It's the thing that looks like a star. It's on the number 8, with the number 8 button on your keyboard. And the name of the pointer. Okay, let's continue. Blah, 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 blah. All right, this is just an example. So, I don't know. Just so that I'm just going to screenshot it. Blah, 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 blah. So you can see, right? Sorry to flashbang you. That's my bad. A lot of people, dark theme, light theme. You can't please everybody. You just can't. Dark theme, light theme. I mean, some theme is better than no theme, To declare a pointer, write the type of the variable or object whose address will be stored in the pointer, right? You can see that's how you kind of create it. This is the initialization, declare initialize. Again, star pointer is specifically designed to store a memory address, right? Those are the little notes. I'll let you read that so I don't have to torture you with my voice too much longer. I'm sorry, I am going to be torturing you with my voice a little bit longer. But I have no choice but to talk. That's all part of teaching. Okay? Kind of need to talk. Why would you use pointers, right? Here we go. Here's some examples. Well, maybe some examples. So far, you've seen step-by-step details of assigning a variable's address to a pointer. In practice, though, you would never do this. What? After all, why bother with a pointer when you already have a variable and access to that value, right? A lot of people might think that, right? I can see people thinking that. The only reason for this kind of pointer manipulation of an automatic variable is to demonstrate how pointers work, right? So we're just kind of showing you, the foundation, right? The steps. Passing by value, right? That's all the kind of the beginner stuff, right? It's all part of the learning process. And then you got passing by reference. That one's fun, pretty easy, right? And then you got what I call passing by pointer reference, right? Essentially, you need one pointer, one memory address, and one dereferencing pointer, okay? So you need 3 parts to guess if you want to look at it like that. Let's continue. Now that you are comfortable with the syntax of pointers, and I hope you are, I like to feel I gave you some pretty good, clear, concise definitions, answers, explanations, whether in a kind or justifiable manner. I don't know. If you're still following along, you are a solid individual and you want to learn, you desire to learn this. I love that. I respect it so much. Quitters suck, by the way. I don't want them back either. Pointers are used most often for 3 tasks. Managing data on the free store. Okay, you'll hear that term, free store. What is free store, right? We're going to find out. We're kind of we're getting away from stack allocated memory, boys and girls. That's what we're doing. Accessing class member data and functions. Passing variables by reference to functions. You would have seen me do that kind of a lot in the beginning. I'll pass by reference. The remainder of this lesson focuses on managing data on the free store, okay? That's the reason for all this, okay? So, just to kind of give you a starting example, if you think of stack allocated, it's kind of like the allocation in memory before you run a program. Okay, I'll just kind of give you the basic understanding, right? That is compiled. That's the point where you have compiled time errors. Before you even run it, you'll see errors kind of down here, right? So when you create variables such as this, we're allocating memory on the stack before we even run it, okay? So there's also runtime memory. So when you run the program or application, there's obviously things are running. There's magic happening on your, system, PC, laptop, pancake, whatever you want to call it. And, right, you can actually allocate on the memory during runtime. Okay, you also can have runtime errors as well, right? Compile time doesn't really pick up on, it just depends, right? So you can have runtime errors. And so runtime is what it's not a term I use a lot, but they call it the free store. Okay, free store. The term I call it is heap allocated memory. Okay, that's dynamic, running, in motion, moving, dynamic, right? Not static. Static, stationary, not moving. Statue, okay? Like a lot of gamers, they're all static gamers. I have to stop to aim to shoot. Okay, I don't mean to go on a tangent, but yeah. Anyways, enough of that. So runtime, heap allocation. And this is where I'm going to be kind of getting into the topic, what I call newing up, right? Newing up. My professor, man, he was amazing. I learned from a pretty smart individual. So anyways, carrying on. So I kind of use the terms that he uses a lot. Newing up. I like it. All right, let's continue. So in this section, how functions work, a peek under the hood. That's actually something, a term you'll hear a lot as well. Okay? right? I may have said it a lot of times as well, under the hood. Okay. How things work under the hood. We'll get to that. We'll talk about it a little more here. Okay, organizing into functions, 5 areas of memory are mentioned. So global namespace, the free store, registers, right? Code space, and the stack. Okay? We've learned about the stack right from the beginning, guys and gals. We've been talking about stack allocation a lot, right? So, and we have gone over the stack. We, the dishes and the plates concept, or the library books concept, right? Whenever you hear the stack, let's see if I can find that, right? Think of that. All right. Need some coffee? I'm just going through the coffee today, boys and girls. Don't forget to buy me a coffee. That'd be great. It would super help. It truly would. I appreciate you. Okay. All right. Let's continue. Now, I think before I get going, let me share. I don't want to get into my GitHub. Yesterday, I was kind of updating my GitHub. I also put, if you're interested in doing the code, I'm going to have it in the video anyways, a link or something to GitHub. I actually have the actual code on GitHub for that one where I built a full class, a rectangle class. And I know I was talking about it earlier and I didn't quite finish. But I did I did a workaround, and I did figure out a solution to where we're having an issue in the switch case. And man, the Microsoft was giving me the example, but I just didn't clue in at the time when it was live, right? I did figure it out after. It was kind of like a George Costanza moment. I was done streaming and I'm like, but that's okay. So the code's going to be on GitHub. You can copy and paste it and keep the code. It's open source, by all means. Sharing is caring, right? Just like I always say, I put in the time, I've written the code, I made your life easier. All you have to do is copy and paste. Don't forget to buy me a coffee. Let's go. And I'm really going through my coffee today, I'm telling you. I'm nursing it, but I'm drinking a lot of it. Okay, so because I wanted to kind of get into talking about the compiler a little bit, and then talking about compile time and runtime. I think this is kind of a point where we should kind of understand and have an understanding of the compiler and understanding compile time and runtime before we start talking about stack and heap, okay? So I have what I'm calling my C++ reference guide, which I've slowly been building over the last year or two, whatever it's been. And eventually I want to kind of make a quick reference guide out of it. It's kind of the plan, the goal. Whether it happens or not, I don't know. It's part of the dream, of somehow making money somehow, so that I could kind of just eat other things other than bologna and wieners, right? So that's the idea. So sharing is caring. I'm going to share with you some of the notes from my code referencing guide, because I'm being nice and kind that way. Do I read this, or do I let you guys and gals just kind of pause it and read it? What's better for you? I think I'll let you read the compiler, right? The compiler is kind of what jumbles everything together when you like click play, sort of thing, right? And then you have the concepts of, wish I could scroll this a little bit better. Compile time and runtime, like I've been kind of explaining, right? Compile time is sort of like when you first click it or before you click it, the play button or the run button. And then when the application's actually running, full on running in like ready, I'm running mode, you got runtime, right? So of course you can allocate memory during runtime as well, right? These are some of my notes. Let's see. Share examples 15, 16. I'm wondering, I have that somewhere, but no, it's just a matter of where is that. Let's see. I don't know. It could be anywhere. I guess I can search it. Of course, just like anything, guys and gals. I have so many file folders. I've got screenshots. I've got lots of saved information. Kind of, all my stuff while I've been learning and growing and doing this dream. And I'm not really finding it in my search. That's okay. So I do, hold up. I do have this though. Let's see if I can find it. It might help. It'll give you a little bit of a visual. Where are you? Here it is. Okay. Just an example I kind of found over the old interweb, right? I decided to screenshot it. The following figure example blah, 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 explains the stages involved during the software program coding. This is to provide context and I can't read today apparently, and how the stages are related. Okay, I'm gonna let you read the rest. Okay, there we go, right? Now you have an understanding. That's why C++ is kind of the faster, because it's like literally one-on-one communication with the CPU, right? And there we go. Runtime is the period of time when a program is running and generally occurs after compile time. I probably should read. Maybe a lot of you are listening to this like an audio book, and I apologize. I should think of you guys and gals as well. We are, just to give you a time frame, I should be reading. I do apologize. We're at time frame 48, almost 49 minutes. And so if you want to go back, I don't know, 5 minutes or so, I have my quick reference guide up on the screen for you. I do apologize, I'm not thinking of these things. Okay, you got to think of you guys as well. Runtime library, and then now we're getting into talking about stack. Okay, stack, right? Well, not really getting into talking about stack, because we already been talking about stack, right? Stack allocation. Stacks are a type of container adapters with LIFO, last in, first out, right? So stack. Right? Stack. Okay, where a new element is added at one end, the top, and an element is removed from that end only when going out of scope, right? The sister curly bracket, also known as static memory. All stack memory allocation sizes need to be known at compile time, right? It needs to be known ahead of time, right? If you got typos or syntax incorrect, you will get errors in the error list. For creating a stack, we must include stack header. It's not necessary, guys, with what we're doing right now, but you do have that ability. You can go learn a little bit more about the include stack header. I haven't really gone into it too much myself, but it does exist, so now you know about it. You are aware. So they're being clear that it's part of the standard namespace, which means you have to put STD colon. Oh my god. These guys are doing Christmas commercials already. What the? Are you on, Bob? It's not even the end of October. Halloween hasn't even happened yet. Unbelievable. That's hilarious. So here, I don't know, society's messed up. They have all these commercials and they throw out all these ads and everything, but they don't want everybody to be successful, right? And it's like you kind of need money to kind of, go out to be able to buy things, right? That's kind of how the world works, right? So if you're keeping people down from being successful, they really can't go out and do those happy things that you want them to do. I mean, if you're keeping people down in society, you don't deserve to have Christmas, nor do you deserve to celebrate it. But those are my thoughts. All right, let's continue. For creating a stack, okay, blah, blah, blah. Don't really need to create that. You can create a stack, I guess. Guys, I'll have to look into it more. That's another video on its own. I want to kind of keep pushing forward with the course outline we're doing. Okay, maybe we'll get into examples. I don't know. We'll see. Programming stacks are based on the principle of last in, first out. Okay, a commonly used type of data abstract that consists of two major operations, dot push and dot pop. You'll hear that when we get into vectors. It's kind of like pushing in memory, popping out memory, right? It's kind of like pushing more rail cars at the back of the train sort of idea, if you think of it like that. Okay? Heap, right? This is what we're getting into. Heap, runtime, dynamic memory. What is meant by heap in C++? I'm going to read, guys, so please thank you for, tolerating my voice. Okay, I'm better at mathematics, terrible at typing, apparently not the best at reading, but I try. I can spell and I can write grammatically correct sentences. So there, joke's on you. In certain programming languages, including C, C++, and Pascal, I guess you could probably pause it and read it and kind of skip ahead if you're like, if you want to just read it yourself. That's a suggestion, and I'm okay with that. It's not going to hurt my feelings at all. You want to learn, and I'm going to be understanding. To me, that shows commitment and dedication still, right? So it's okay, all right? I'm not going to go cry in my cornflakes. I'll be fine. A heap is an area of pre-reserved computer main storage memory that a process can use to store data in some variable amounts that won't be known until the program is running, i.e. runtime. Heap memory is essentially a large pool of memory, typically per process, from which the running program can request chunks of memory. This is typically called dynamic allocation. Memory allocation, which depends on runtime variables, dynamic memory size must be heap allocated. Dynamic basically means memory's changing, right? It's alive, guys. It's alive and constantly changing. The OS finds a contiguous chunk of memory. Contiguous, just think of a train. Woo woo! One rail car after another. Woo woo! Choo choo! Woo woo! Choo choo! Okay? You hear the term contiguous? Just think of that. What's this? Oh, here we go. I did find my example that we were kind of looking for. I'm going to continue reading, and then I'll read that little pop-up after. Okay. The OS finds a contiguous chunk of memory and returns a pointer to it, right? Remember the when things are happening, the memory has its own pointer. Do you remember with registers, and all that stuff we kind of talked about? We don't really need to go deep into the understanding of how that works. It's just one of those concepts. Be aware of, know about it. Now you know it, right? That's all you need to do. That's all. You just need to know about it, right? Whatever happens, whatever the memory and the CPU is doing during runtime of an application, that's out of your control anyways. Okay? It also very complicated and expensive on memory. Okay. So here, this is the newing up, right? So whenever you see the new keyword, right, that's newing up. If you see the word new, you automatically store that in your mind. Heap allocated memory, that's dynamic memory when you see the word new. Okay, int pointer hval equals new int. Okay, creating a pointer, newing up. Heap holding a memory address, int pointer hval is the pointer name, here declaring a pointer. And then you could obviously go I don't know why we would need the pointer again. Note here dereferencing above pointer to set or assign a value to it. Normally you could just initially just assign it because you've already said it's a pointer. So I'm going to leave it like that. It feels like it's wrong the way it was typed there. If you need to allocate a large block of memory, example, a large array or a big structure, and you need to keep that variable around a long time, like a global, then you should allocate it on the heap. All right? That makes sense? You don't want, so, right, remember things go out of scope, right, when it hits the sister curly bracket. Okay, if you need that variable to stick around, you do newing up. The heap data structure can be implemented in a range using STL, which provides faster max or min, item retrieval, and faster insertion and deletion on sorted data, and also works as a subroutine for heap sort. Right? If your goal is to work with large databases, you're definitely going to want to learn this area. Okay, and then we have, when we're kind of getting into, are these part of vectors? It feels like they are. They could be C-stack and CS20. I have to find that example. Where is that? I might have actually an image of it. We don't need to return. We don't need to. I'm not sure what I was trying to get at there, guys. All right. Too many tabs open. I want to see if I can find that. I did find one of them, one of my examples that I'm going to share with you. But that other one, I'm just trying to think, where is that one stacking in? Unless it is this, let me just see. Or is it this? Could be this. That's 15, example 15, I don't know. I'll have to look for that. I'll try. The main differences are stack. What are the main differences between stack and heap? Let's see. When a program is launched, the operating system, the OS, I should just say. If you hear me say OS, that's what I mean. Gives access to the two different types of memory in C++, stack and heap. Both stack and heap are stored in RAM. At a basic level, both just store data. Stack memory has a predefined size, like a few megabytes. Very easy to run out of stack memory. And then you get into a situation which is called stack overflow. That's a no bueno. That's a topic in itself. Local variables without new are allocated on the stack by default, right? If there's no new, it's just stack out. That's how I know, right? As soon as you see the new keyword, just think dynamic and heap. Program function call returns addresses are also allocated on the stack. Program function calls return addresses. The main differences are the size of available memory, the way memory is found and allocated, the speed of memory allocation, the way we request memory in our code. Stack memory deallocates when it goes out of scope. We all know that, right? Here's the housekeeping part I've been kind of talking about and just hinting to you guys and gals, right? As a C++ coder, when you're newing up, you have to become a housekeeper, okay? You have to clean up your own memory, cleaning up after yourself a little. Oh my God, Batman, stop it. Thank God there was no talking in that commercial. Get skipped. Thank you, commercial, for not talking. I appreciate you. Okay, heap memory will remain in the heap if not removed. And then you'll get what's a term called a memory leak, right? Because it hasn't been cleaned up, guys, right? That's a no bueno. So you have to use the keyword delete. You actually have to type delete. Okay, and we'll do examples. Heap is used when we need a large memory variables to be used globally. And resizing is to be done frequently, whereas stack is used when the small variables need to be stored till the execution of function only and no very less resize. I kind of brutalized that sentence, and I just apologize. That's it with that. We're done with that. Let's get into some other examples. Differences, I probably should have just read this one. The following table shows a comparison between compile time and runtime. All right. Compile time. Time period for translation of a source code like Java to intermediate code like .class. Compile time, this is to check the syntax and semantics of the code. Okay, little things, right? That's when you'll get errors in your error list. Syntax and semantics. Errors get detected by compiler without execution of the program. Okay, fixing an error at this stage is possible. Okay, runtime. Time period between start and end of running intermediate code at runtime environment. This is to run the code and only can detect after errors, okay? Only can detect after execution of the program. Fixing an error requires going back to code, okay? Right? Because it's not going to really give you an error. You kind of have to become a detective in a sense. Okay, Back to the course outline. It's kind of easier for me to read from the other screen versus this my right monitor. Coffee. Oh yeah. Can't get enough of it. Local variables are on the stack along with function parameters. Code is in code space. This is right now kind of the audio. I can't even think of the name right now. Hold up. Too many tabs open in the brain. Too many words going on. It's insane. That's okay. We shall get up and persevere. Regardless. What am I doing here, Batman? Get with the program here. Unbelievable. Can you click the right program? Unbelievable. I'm looking for this, is what I'm looking for. Audiobook. Wow, why couldn't I think of audiobook? That's crazy. Okay. This is the audiobook portion for those of you that learn by listening, because we all have different ways of learning. Local variables on the stack are on the stack. Okay? Right? That's why I always put these little notes here. Local variables local to int main. Okay? It's all right there. Code is in code space, of course. And global variables are in the global namespace, right? Global is above int main. I'm kind of getting frustrated with myself the way I can't even speak today. Get with it, Johnny. Right? So global variables are above int main. It's also an area where you can write classes. If you wanted to, you can. It's also the same area where you do all your function prototypes. The registers are used for internal housekeeping functions, such as keeping track of the top of the stack and the instruction pointer. There it is, the instruction pointer, right? The registry is the instruction pointer. That's kind of all the under the hood stuff that we don't really see, right? Such as keeping track of the top of the stack. Okay, read where you're supposed to read. Just about all of the remaining memory is given to the free store, which is often referred to as the heap. Heap. Whew. Okay. Local variables don't persist. Okay? When a function returns, its local variables are destroyed, right? As soon as it gets out of scope. Once it leaves the function, that's it, right? Local to, like, especially local variables to a function, bye-bye. This is good because it means the programmer doesn't have to do anything to manage this memory space, right? That's why we don't have to do any housekeeping, guys and gals, with stack allocated, because the sister curly bracket's doing all the work for us. Isn't she amazing? Continuing on. Okay, where are we? But is bad because it makes it hard for functions to create objects for use by other objects or functions without generating the extra overhead of copying objects from stack to return value to destination object in the caller, right? I know that was a little bit, right? So obviously when things are getting cleaned up, it's good. But you can't kind of carry, the problem is you're not able to kind of carry those updated variables or values to other code if you wanted to, right? Okay, again, so but is bad because it makes it hard for functions to create objects for use by other objects or functions without generating the extra overhead of copying objects from stack to return value to destination object in the caller. There's a lot of back and forth going on, I know. Global variables solve that problem at the cost of providing unrestricted access to those variables throughout the program, right? But creating global variables is kind of frowned upon as well, guys. Okay, I tend to do it. If I'm not releasing anything, I don't care. Okay. Where am I here? Which leads to the creation of code that is difficult to understand and maintain. Again, if you have an understanding kind of what's happening, a little bit of an idea of the magic that's happening under the hood, I don't think you're going to have any problems figuring things out. That's my take. There's always lots to learn. We're always going to have stumbling blocks. Always learning. Positive, open mindset, boys and girls. A positive, open mindset. Putting data in the free store can solve both of these problems if that data is managed properly, right? That makes sense now? Why Heap allocated is a thing, right? Because when things go out of scope, we can't continue using those values. Let's say your program needs that updated information. Well, if it gets cleaned up, you can't use it again. So hence why we take advantage of dynamic memory, also known as the free store. You can think of the free store as a massive section of memory in which thousands of sequentially numbered cubbyholes lie waiting for your data. I used a lot of different terms, shoe boxes, containers, they call it cubbyholes. However you want to look at it, it's up to you. Train cars, rail cars, library books. You can't label these containers, though, as you can with the stack. You must ask for the address of the container that you reserve and then stash that address away in a pointer. That's why that stuff's done, guys and gals. Okay? Part of the registry, right? Imagine that's what's happening in the registry, right? One way to think about this is with an analogy. Okay, let's see if their analogy works here. A friend gives you the 800 number for Acme mail order. Okay, why am I thinking of Willie Coyote? You go home and program your telephone with that number. We don't normally have to, but that's okay. All right, and then, well, I guess you can put an area code on your phone, but like you could actually store the area code on some phones nowadays. Anyways, it doesn't matter. So you go home and program your telephone with that number, and then you throw away the piece of paper with the number on it. If you push the button, a telephone rings somewhere. An Acme mail order answers. You don't remember the number, and you don't know where the other telephone is located. But the button gives you access to Acme mail order. Okay? Acme mail order is your data on the free store. You don't know where it is, but you know how to get it. You know how to get to it. You access it by using its address. In this case, the telephone number. You don't have to know that number, you just have to put it into a pointer, which is what they're calling the button. The pointer gives you access to your data without bothering you with the details. That was just a slight analogy, guys and gals. You don't need to understand the Acme story, but you just need to kind of understand the pointers and newing up and all that. The stack is cleaned automatically when a function returns, right? All the local variables, that's the LIFO, right? LIFO process. All the local variables go out of scope and they are removed from the stack. The free store is not cleaned until your program ends, and it is your responsibility to free up any memory that you've reserved when you are done with it. Okay, we just basically, in a nutshell, you have to manage your heap or dynamically allocated memory, right? That's all you need to remember. You don't have to worry about stack. It's all done for us. Again, the sister curly bracket does all that. But when you're newing up, it's your duty. It's your duty as a coder, as a developer, to manage the memory. You're making your program better, right? Who's going to want to buy your sluggish, cruddy program if you're not managing the memory? Right? If it's lagging and doing all weird stuff and breaking and crashing, and you got leaks and stuff, like, it's just gonna be, right? You don't want to make a trash program, guys, so you have to take the responsibility. Okay, and plus for me, I don't care about this. I don't mind this. Like, how hard is it to type the word delete? I could show you how to create your own class where you could actually set it up where it does the cleanup for you. It's pretty cool. And then you don't even have to bother worrying about it, because once you set up the class, it's like you kind of created your own housekeeper. It's great. Stay tuned if you want to see that. Okay, let's see. Where am I here? The stack is cleaned automatically when a function returns. All the local variables go out of scope and they are removed from the stack. The free store is not cleaned up until your program ends. And okay, I know I'm reading that stuff again. Okay, and it is your responsibility to free any memory that you've reserved when you are done with it. This is where destructors are absolutely critical. So this is why the concept of destructors is created. If you've been kind of watching the series, and I've been talking about, you don't need destructors when you're stack allocating variables, or you have stack allocated objects. You don't need a destructor. You can create them. You can still do that, but again, they're not really doing anything because the sister curly brackets are already on it. She's already on it. But you could put it like a standard cout and a couple of 3, like a little tilde and 3 asterisks, just to represent that, that it's actually working. But it's more of a visual thing, I guess. Right? So to explain, that's why I put these extra empty scopes brackets, curly brackets, so that we could actually see, a destructor doing its job. Because when it gets to the sister curly bracket of the main, that's it. There's nothing else being shown after, right? Hence why the empty scope, so you can see it. Okay. The advantage to the free store is that the memory you reserve remains available until you explicitly state you are done with it by freeing it. If you reserve memory on the free store or on the heap, it's another way that it's said, while in a function, the memory is still available when the function returns. Okay? The disadvantage of the free store is also that the memory you reserve remains available until you explicitly state you are done with it by freeing it. I feel like that's deja vu reading. Anyways, if you neglect to free that memory, it can build up over time and cause the system to crash. Okay? You basically, you need to free up the memory so that it can be utilized again, right? That's the reason why it's being cleaned up. You only have so much memory, guys, gals. Once you fill it up, then it's kind of like filling up a bucket of water. Eventually, if you keep filling it, it's going to overflow. The advantage of accessing memory in this way, rather than using global variables, is that only functions with access to the pointer, which has the appropriate address, have access to the data. This requires the object containing the pointer to the data, or the pointer itself, to be explicitly passed to any function making changes, thus reducing the chances that a function can change the data without that change being traceable. For this to work, you must be able to create a pointer to an area on the free store and to pass that pointer among functions. The following section describes how to do this. A little bit more reading, guys and gals, but we are going to kind of, we've already done some examples of pointers. We'll type up some more code here. There's some. We're going to be doing some typing here shortly, and then we're going to get into using the delete keyword. So we're going to do examples. It's great to have you. All right. Allocating space with the new keyword. That's what we're leading into, and I need to clean this all up still. Where am I here? Today's lecture. And I'm going to clean things up. That is from last stream. You have to be part of that to see that. And yeah, there we go. I like that. We'll keep that. And we're going to go like that. And then I'm just going to build. We don't have any functions. We didn't create anything like that. These are just my standard functions. That's all. All right. Okay, so just cleaning up the program a little bit so we can write some code. A little more reading though. You allocate memory on the free store in C++ by using the new keyword. NEW. New is followed by the type of the object that you want to allocate, so that the compiler knows how much memory is required. Therefore, new, unsigned, short, int, allocates 2 bytes in the free store. Now again, you gotta take note, guys and gals, this is an older course outline that I'm following. Newing up and all that hasn't changed over the years. But what is different is that the time frame they're writing this, they're 64-bit operating systems may have been slowly being developed at the time. I don't know. When did they release? It's a good question. I don't even know this. When did the x64 come out? Okay. Just a vague question. x64 was announced in 99 and became available when the AMD Opteron processor family in 2003. It was released for Microsoft in the form of Windows XP Professional x64 Edition. And then Windows Server, that's an IT thing, Windows Server 2003 x64 editions in April 2005. Okay. All right. So, but anyways, the point is that when they said 2 byte, they're still on the 32 or FAT32 x86 architecture. On a 64, it'd be 4 bytes. That's what I wanted to kind of clarify. So therefore, new unsigned short int allocates 4 bytes in the free store, and new long allocates 4, probably the same. We'd have to look at it. Again, that's kind of why you need the chart. How are we doing for time here? You know, these lecture theories can get a little long. W, let's go. White and Hood Rich, let's go, brother. Appreciate you. I'm just seeing the stream now, bro. Bro, I appreciate the support. Thank you for following. You're a legend. I mean that. Okay. And he's dropping a W in chat. I love it. Let's go. When I'm reading, I'm not really watching the chat. That's the problem, right? Hang on a sec. Whoops. Appreciate you being part of this and learning along. What the am I doing? Goodness gracious. Get canceled. Okay, I'm not the canceling type, but I can't type worth a darn. Let's go. Let's go. All right, I just need this. Let's go. Okay. Let's go. All right. Yeah, let's go. Man, you're cool in my books, my guy. Let's go. All right, I'm going to continue. Appreciate you stopping by, saying W. That helps. It helps, man. Even if it's just a simple W, I love it. It's awesome. All right, where was I? Blah, 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 blah. Okay. The return value from new is a memory address. Okay, there's a key point right there, guys, gals. The return value from new is a memory address. So you can think of that as well, just like when we use ampersand, think memory address. You can also think the same thing with new. If I could type new. Am I new? I must be new. Okay. Think memory address. Ampersand. Think memory address. Okay? Correlate those together, boys and girls. Correlate them together. Let's drop the yays, because we can. Let's go. Now, there we go. Yeah! See, there's the W. Check that out, bro. I got you up. I got you. You got me, I got you. I got your back, bro. I got your back. Let's continue. You can, of course, do this all. Hold up. Because you know how that memory addresses are stored in pointers, it should be no surprise to you that the return value from new should be assigned to a pointer. To create an unsigned short on the free store, you might write, okay, let's just do it. Whoops. I'm just going to type it, unsigned. They use a lot of the not so common data types, which is fine. They're trying to, I don't know, maybe look fancy. That's okay. I still appreciate the use of their lecture course outline and the time they put into it to create it. So right here, guys, before I even go any further, remember earlier I said, let me just look. Do initialize all pointers either to a valid address or to null. Okay? So if you're using Visual Studio and you see the 3 little dots underneath, you should automatically already know what that means, right? So we have to initialize. The program's just saying, hey Bob, you got to initialize. What's up? Okay, so that's to create an unsigned short on the free store. All right, we just created it. Right now it's equal to null. I guess it would technically have a memory address still, because we'd still have to store the null, I guess. I don't know what the code behind is for a null pointer. I never really looked at it. But you can still peek that stuff. And then we take the actual name, right? So we've already told the program. We're telling the compiler, hey, compiler, this is a pointer. Okay, this variable here is a pointer. Okay, we've already told it that it's an int data type, and we've told it 2 things: that it's an int, and we've told it that it's a pointer. So because we've already done the declaration part, we don't need to type any of this stuff anymore. We're done with that. So we could actually just type the name. Okay? That's why I removed that dereferencing pointer earlier. And then now we're basically assigning it to newing up stuff. Okay? This is basically the point where you're creating space on dynamic memory, in a sense. I don't know how the best way to say that, but right, that's what we're doing here. Right here's the newing up part. Creating space on dynamic memory. Okay? I could have inlined all this. I didn't need to do all this extra stuff. So, whoops, what am I doing today? Oh my god. Okay, let me just do this. I call it inline. It's all the same. I could just go like this. Okay, instead of going, like, I could initialize it, I guess. Just depends where you're doing it. I could one line it. Okay, so it's just another way of writing this. It's the same thing. We've done everything. So here we've 2-lined it. Okay, that's 2-lining, if you want to look at it like that, right? 2 lines. Here I've inlined it, or 1-lined it. Okay, so a lot of times you might... let me just show you something here. I'm just undoing right now. Okay, so you will see 2-lining. You will, right? So typically this is the line that might be down here, right? That's why you would be 2-lining it. Myself, I like to kind of, when I'm creating stuff, I have a local variable section. Here's the main, right? You don't need all these extra notes. These are just notes for you guys and gals. You would not normally have all this. Okay, it's a little messy, but you wouldn't see all this, not normally in code. Okay, these are just notes for you guys to learn with. Okay, so I would kind of declare it. I would declare it up here, right? And then I would null it, right? It's kind of like the initializing. And then I would call it here in my empty scope or somewhere down my code. All right, that's why you would, technically speaking, new line it, right? I mean 1-line it, my bad. So there you go. Just 2 different ways of doing things. It depends on what you want to do, okay? You can do it right up here as well. All right, so you can, of course, do all this on one line by initializing the pointer at the same time you declare it, right? In either case, p pointer now points to an unsigned short int on the free store. You can use this like any other pointer to a variable and assign a value into that area of memory by writing. Okay, so I guess the other point is you wouldn't really be doing this. Here we're actually creating the memory, right? So I could actually keep that like that, right? Probably a good idea, right? We're creating a pointer and we're newing up. Okay, creating a pointer and newing up. Creating a pointer and newing up. Just kind of repeat that in your head, right? Once you get into the rhythm of doing this, you'll know what you're doing when you're doing it. Right now, as a matter of fact, I could change this. So I could change this to heap allocated. There is some kind of blah, blah, blah. So it's not on the stack anymore. We're not even doing on the stack. Let me just see if I can find something. Some of my old notes. What do I usually normally type when I'm doing this sort of stuff? Just need a main here. Okay, that's not gonna help. Sorry I'm taking this extra time, guys and gals. You know I appreciate you. Goodness gracious. I'm just trying to, the way I talk, I'm trying to keep it, kid friendly. Stack objects. Heap allocated, I guess stack. No. Heap allocated pointer. My bad. Okay. Plus newing up. Okay, there we go. And here, Control X, and I'll just go like this. Okay, there we go. I'm going to have errors because I haven't finished here. All right, let's continue. So now I have to actually give it a value. So, all right, yeah, I did need. So that's kind of, yeah. Okay. All right. So earlier, right, I did mess that up a little bit. What I had there earlier was correct. Okay, I'm just kind of cluing in a little bit here now. Okay, right here. Let me just put that back. Okay. All right, so I removed the dereferencing. This is the dereferencing asterisk, if you want to call it. I removed it because you can actually assign it, but you got to really think about this variable is an address, right? So we can't say an address equals a number. You know what I mean? You know what I'm saying? This is the dereferencing, right? So we're dereferencing it. We're turning it from a variable that holds a memory address to a essentially we're transitioning it into a, I don't know if it's the right way of saying things, but just think of it, you're turning it from a memory address variable to a variable that can actually be equal to a number. Okay? I mean, that's kind of the easiest way I could put it. That's the reason for dereferencing, right? So I actually do need to dereference this, right? Without it, it's a memory address, okay? It's a variable holding a memory address. As soon as I put the dereferencing, what is the other name they called that? I don't know. There's so many different names. I just call it the dereferencing pointer. No, that's actually wrong to say. I hate saying asterisk or strongly dislike. It's for dereferencing. Okay, so I've now turned this variable into something that can hold a numeric value. That's why I could do this. Okay, so let me show you something. If I kept this without it, it's gonna break. It's gonna not like it. So I would actually have to, I don't know, this is gonna be wrong as well, but some random hexadecimal. Okay. That's not going to work either, right? What is hexadecimal? Okay. You know, right? So let's just pretend this is hexadecimal. I know I brutalized it, but you get the idea, right? They equal, it works because they're the same thing, right? That makes sense? This is a memory address. This is a memory address. It's like a teeter-totter. It's a balancing thing, right? One side has to equal the other side, numerically or in a data type sense, right? So, hopefully that makes a lot of sense, and that's why we add the dereferencing asterisk, so that we can, because now this has become a variable that could hold an integer. All right, I know that was kind of maybe over-explained, but hopefully that explains it, okay? In this case, P pointer now points to an unsigned short int on the free store. You can use this like any other pointer to a variable and assign a value into that area of memory by writing, just like I've typed here. This means put 72 at the value in P pointer. Okay, the P is like pointer, and then the name doesn't really have to be pointer. I could have called it P Bob's turkey dinner. Okay, I could have called it that, right? The P still means pointer. Okay, guys. All right, so that's what that means. So they have their definition or way of explaining things. I kind of have mine. Hopefully mine helps. I will read the lecture outline. Hopefully it doesn't confuse you. Some of it may be a little confusing, but I try to give kind of my analogy and help you guys learn, right? It's kind of like a balancing game, right? This can't equal this. This can't equal this unless it actually is that, right? It has to be we're transforming it. Think of it like that. When you're dereferencing, you're actually transforming, which is a word I'm not a fan of, but anyways. If new cannot create memory on the free store, memory is, after all, a limited resource. It throws an exception. Okay, and then we'll get into handling errors and exceptions in the future. In the future! The future! Let's go. All right, how are we doing for time? We're getting there, okay? Putting memory back, okay, let's continue. Putting memory back, the delete keyword, okay? Putting memory back. So this is all the allocating. Now we have a value actually assigned. Where is that? Right here? Right here, right? Boom. Okay? Putting memory back. Excuse me, guys. When you are finished with an area of memory, you must free it back to the system, okay? Think of it like the library, right? You're removing the books. Okay, we're done with the books, now you gotta remove the books. When you're newing up, you have to become the housekeeper. You do this by calling delete. That's why I didn't run the program, because I really don't like the concept of having dangling memory. Delete returns the memory to the free store. It is critical to remember that memory allocated with new is not freed automatically. It is not freed automatically. If a pointer variable is pointing to memory on the free store and the pointer goes out of scope, the memory is not automatically returned to the free pointer. So the pointer can go out of scope, guys and gals, all right? Rather, it is considered allocated, and because the pointer is no longer available, right? Because it would still, like, remember, it's the guy in the street pointing to a house, right? Kind of analogy, right? If you remove the guy pointing, well, the house is still over there, right? So we got to kind of delete the house, if you want to look at it like that. Okay? So rather, it is considered allocated, and because the pointer is no longer available, you can no longer access the memory. This happens, for instance, if a pointer is a local variable. When the function in which that pointer is declared returns, that pointer goes out of scope and is lost. The memory allocated with new is not freed. Instead, it becomes unavailable. It's kind of there floating in limbo in the memory, right? Essentially, right? That area in memory hasn't been cleaned up, right? You can't put anything into it if it has something there, right? So it's kind of like dangling memory. This situation is called a memory leak. It's called a memory leak because that memory can't be recovered until the program ends. It is as though the memory has leaked out of your computer. To prevent memory leaks, you should restore any memory you allocate back to the free store. You do this by using the keyword delete. Okay, so I'm going to scroll here. Delete. What the English? I really strongly dislike typing. When newing up, you must become a housekeeper. Housekeeping! Housekeeping! Can I fluff your pillow? Just kidding, guys. I don't want to fluff your pillow. Unbelievable. Let's go. So somewhere down code here, you would kind of do it right before. I guess. Well, no, you would still want to be inside, right? Normally, you don't have these empty scope curly brackets. This isn't normal, but I do this just so I could kind of see the magic with the destructors. But you would do it before it hits this curly bracket. Okay, so here's where you would type delete. And then you just copy the actual name and delete pointer. Okay? And then you drop the yays because you're awesome. I want to recommend a song. You guys like metal music at all? I want to recommend a YouTube channel, but I don't know. Let me know in comments below. I like metal. Old school, man. I was into Metallica. Still into Metallica. I love Metallica. They're the jam. Okay, let's continue. Not to get off on a tangent here, but there you go. So I could actually run it. Things are going to be fine. That error went away, right? Nothing's being printed. We're not displaying anything, but we're actually allocating memory and then we're deallocating. Really, that's what we did. I don't have any constructors. I don't have any destructors. So therefore, I can't really show you the deallocation process here, right? So yeah, it's good practice, right? It's not stack allocated anymore. So I'm just gonna cut this, and well, I'm gonna go like this, okay? Heap. I need to change it, right? All right. Okay. So yeah, there you have it. So we're declaring, we're initializing, still declare initialize, right? We're assigning, we're asking for space on the heap, right? During runtime, that's what we're doing. We're asking for space in memory, and that much, the space determined is determined by the data type. Okay, and then we create our pointer. Well, we've already created the pointer name. I have to put the dereferencing. What is it that they call it again? They have their own name for it. I don't use that name much, so what do they call it again? Dereference operator? Okay. All right. That's what we're doing here, right? Using the dereference operator. You got to kind of have an understanding, like I was trying to explain in the last video, pointer video. Hopefully, you guys understand at this point. This is doing its own thing. It has its own purpose. It's like a different person with a different shovel. Okay, it's doing a different task. Okay, this is its own task. It's doing its own thing. This is a person. It's pointing. He's the guy in the street pointing, and this guy's kind of over across the street, probably at that location, and he's like saying, "I have a number here." It's different. These aren't the same. This isn't this one. This is an individual. This is another individual. Okay, however you want to look at it. They're doing two different things. Okay, two different tasks. Where am I? So we've gotten to the delete pointer, and that's kind of what I wanted to get to. So that's to prevent memory leaks. Use delete pointer. Whatever your variable name. Your variable name is going to be something different. I recommend putting PTR. You could put PTR pointer. However you want to type your variables, that's kind of up to you. You can type PTR, short for pointer. It's up to you. Okay, or just have P. Okay. When you delete the pointer, you are really freeing up the memory whose address is stored in the pointer. So you think about it, you're also being nice to your computer, right? This is healthy for your computer to do this as well. Okay, so I wouldn't complain about this too much, right? If you love your computer, you're going to want to do that. Okay, it's computer friendly. You are really freeing up the memory whose address is stored in the pointer. You are saying return to the free store the memory that is pointer points to, that this pointer points to. The pointer is still a pointer. That's a lot to say, and it can be reassigned, right? That memory is freed up. It can be used again. Okay, demonstration. Most commonly, you will allocate items from the heap in a constructor and deallocate them in the destructor, right? That's when you're creating classes, okay? I'll show you how to do that, guys and gals, all right? In other cases, you will initialize pointers in the constructor, allocate memory for those pointers as the object is used, and in the destructor, test the pointers for null and deallocate them if they are not null. Right, that's something else I've seen as well, where some people will actually, I think it's maybe with just arrays. This is just a pointer, but with an array, you might see like null, right? Something like that. You might see it done 2-line. This is like really making sure. Okay? It's like making something 0. Okay? I don't think we need to. I think it's common with an array to do that. So, but this is just a basic pointer. We haven't gone into arrays yet. We'll get there. We're doing the fun stuff first. Okay. Where are we here? In other cases, you will initialize pointers in the constructor, allocate memory for those pointers as the... let me carry on here. When you call delete on a pointer, the memory it points to is freed. Calling delete on that pointer again crashes your program. Wow. Once it's deleted, you don't need to do it again. That's just being a dirt burger. Okay, when you delete a pointer, set it to 0 or null. Okay, so yeah, okay, so they did say you can. I've seen it done with arrays, like I said. An array is how you tell what an array is. It uses these square boxes. Okay, when you see these 2 square boxes, it's an array, but we'll get to that in the future. Okay, it's not that important right now. Okay, goodness gracious. All right, there we go. Okay, that's really cleaning up. Okay, that's making sure. Calling delete on a null pointer is guaranteed to be safe. Okay. All right, so that's a little extra protection in case somebody dirt burgers and tries to call delete on it again. Sets the pointer to null is what we're doing here. And then we can call delete again, and it would be harmless. That's kind of what they're getting at, right? So if I call delete again, harmless to the program. Okay? Only because I have null. Okay? Without it, bad. Okay, I have never seen anybody call it double delete, but I guess there are people out there. Okay, I do have a little program. How much time? Do I have time to type up a little program? I'll do it quick and sweet here, okay? I'll try to. All right, I didn't want to go into overtime, but whoops. We're going to clean up here. And we're going to clean up here. And that's all we had. Okay, let's grind some code. Something for you guys and gals to practice. So I'm going to go up here in my local variable area, close to my main at the top, right? Again, all of this is all redundant, guys. Like normally you wouldn't have all this, right? Okay. So I'm just going to create a regular integer, and we're going to call it local val. And I'm going to initialize it to 24, sure. Okay. This is just a regular integer data type. I've assigned a whole number 24 to it. Okay. So now I could actually create a pointer to point to this. Okay. This is, remember, this is stack allocated here, right? This is stack allocated just by looking at it. Right? Stack allocated. All right. So now let's create an int pointer. And we're going to call it, I guess, p-local. Okay, all right. So it's going to point to this local variable. And remember, if you guys have been watching the pointer series, I hope you have, right? So now this is a variable that's going to store a memory address. We have to make the teeter-totter, we have to balance things out here, guys and gals. We have to balance things out. Left side is a memory address, therefore the right side also needs to be a memory address. Okay, it's really that in a nutshell. So I'm now going to new up. So I'm just pointing, I'm storing the memory address of local. That's all I'm doing here, okay? Storing or pointing, right? The guy's pointing to the address kind of concept. Or storing the memory address of this variable here, right? Okay. And now let's new up. Okay, now we're going to be doing some newing up. Okay, Heap. I guess I could have called this P stack. This is still technically stack, right? Okay. And here we're newing up. So this is guaranteed heap memory, okay? We're asking the compiler to create memory space that's integer, however, right? That's four bytes of memory, so it's going to allocate 4 blocks of memory. Okay, 4 containers. Remember, each container is 1 byte, so 4 containers, 4 bytes. Think of each container like a shoebox if you want. Okay, or it's a big shoebox holding 4 little shoeboxes. However you want to look at it. Okay, so this is newing up. Now we're newing up. Okay, that's what I call newing up. I got that term from my professor. Okay, and so now we want to store a value in that. So to store a value in this, we have to use the dereference operator. Okay. To store a value. Right? Again, this is part of the teeter-totter. Right? The left side has to be an int, the right side's an int. Okay? So why is my... So now I'm going to make the right side an int, but I want to use a different value. So I'm going to use 37. So that's kind of pretty obvious which is what, right? Or I could go maybe 87, 67, okay? Or 57. Something so that we're like pretty clear that they're 2 different numbers, right? Okay, so now so there we go. That's all part of the, initializing and all that, right? Okay, so now we made this pointer equal to 57, okay? We could do this magic. We can now effectively change the value of the local variable. So watch this, right? So I should actually go here with this. Okay, there we go. All right. I don't need to null it. There's no sense nulling here because I'm making it equal to newing up, right? So that we don't need to null pointer it. Okay, there's no sense. All right, so standard cout, and let's return the local variable. Okay, let's see the values. Okay, let's see Let's see what happens. What's up? Okay. And then we're just going to return the local variable. If you guys and gals kind of know what's happening here, all we're going to be doing, again, remember codes run line by line, right? So when it gets to this line, it's going to return to the user in the console the most recently stored value in memory, okay, or wherever, right? This variable has its own memory address too. The stack knows where to look for it. Should I go like this? I guess so. There we go. So looking at this, you should go here and go, okay, it should return 24, right? Because we haven't changed anything. This is the most at this point, 24 is the most recently stored value in memory, right? Nothing's changed. Okay, let's go standard cout. I'm trying to hurry this up. And let's see what the value of p-local is. Okay, remember we have to dereference to see it, right? So I'm going to go like this. If I don't dereference, I'm just going to see the memory address, right? Remember, it holds a memory address, right? So I have to dereference to see the value. Okay, that's the job of this. I want to see the value. I don't want to see the memory address. If I get rid of it, it's just going to print the memory address, right? That's the difference. Okay. And then p-local, and let's do the other one. Cout p-heap. Okay? And it's the same thing. If we want to see the value, we have to use that. Okay, so I'm going to go like this. I'm just going to copy this, and then I'm going to copy p-heap, and then return p-heap. Okay, so all we're doing is printing out the value of local. We're going to see what the value of p-local is. Okay, right? Remember, what's it equal to, right? If you're wondering, what's it equal to? It's going to equal to whatever local is holding, right? So we should see 24, 24, and then we should see 57. Okay, let's run that. Do you understand? I hope so. I'm going to run it, and let's see. 24, 24, and 57. Let's go. I messed up with my code, though. I have to fix it, but I'm going to do this anyways. I didn't create that extra space that I like. I don't like that. So there we go. Let's run it again. Remember? 24, 24, and 57. Drop the A's again. Okay, so the reason this one is printing 24, guys, okay, it's because it's equal to, right, it's pointing to the memory address of local. Local is holding 24, therefore it can kind of access that number, even though it's pointing and it's across the street pointing, it has long arms and it can reach and it grabs that value 24 from local variable. That's why you see 24 there. And then of course naturally you're going to see 57 because that's what p-heap is. We assigned 57 to p-heap. Okay, nothing special or secretive there. Okay, well, I didn't do any deleting, which I should have done, so we have to delete p-heap. Okay, I didn't do my cleaning up, which I should have first. Okay, and then let's see what else they got here. So p-heap equals new int. Okay, so all right. Okay, this is just for demonstration purposes only. You don't normally see this kind of code after a delete. It's not common. But here now we're kind of reassigning. We're asking for memory again. Okay, essentially, we deleted it. Now we're asking for memory again. And then what we're doing is reassigning the value to, I don't know, let's just go 107 or 104. Okay? And then we're going to print P heap again. Let's see what happens. Okay? And then I got to make sure I delete it again after. All right, there we go. Okay, let's see what happens. Do I need extra enters? Maybe. Let's go like this. And I'm just going to go a couple of enters. All right, let's see. 104. Okay. So this is just an example. You know, you could delete it and then you could reassign it, reallocate new memory. It's probably got a different address at this point. Like if I actually printed the addresses, they'd probably, again, we don't have any control of what happens under the hood, right? So we're asking for new memory address or memory space on the heap. We've reassigned. We could do this stuff. We could reassign these values. I could actually reassign the value of local 24 through this. Okay? I should show you examples. Right? And I'm cleaning up now. Do we have to clean up our pointer as well, guys? Probably. Should be, right? Our pointer as well, we should be cleaning up. Okay, pointers equal to local. Well, actually, I'm just trying to think of that. I'm coming to think of it. Do I have to? This is different to what this is doing, right? This is the newing up. The newing up, you definitely have to delete. I'm trying to recall. Do I? No, I don't think so. No, I don't. I don't. Right, because it's stack. That's why. Okay. All right, so I had to kind of stop think there for a second, right? It only took me a couple of minutes. I didn't waste 8-hour day of my boss's income trying to figure that little kind of thing out. Okay, watch this. Let me show. I'm going to get rid of this. I'm going to delete this. I still want to keep delete heap. I better keep that because that is a pointer or a newing up. Because we are newing up, right? Where's my newing up? Because we are newing up, we must use keyword delete. Okay? I always do that with because. It's one of those other words that I always have to fix all the time. Okay, so check this out. Watch this. Okay, so technically I don't need p heap. Just ignore p heap. You get the idea now, right? Okay? Let me show you something here. I don't need to print this anymore either. We don't care about it. Who cares? Okay, watch this. I could actually, so local var is 24 right now, right? Okay. I'm just trying to recall here how to do it again. So p heap. So if I print local var, let me just print it. Right? Because I've kind of put a sign. Hold up. No, I'm looking at the wrong one. Silly me. Watch this. Let me show you something. Star local equals, I don't know, 127. Just so that you could actually see, right? So check it out. I'm reassigning the values stored at plocal. Okay, plocal is holding the address of the local value or local variable. I should have called it local var, but whatever, it doesn't matter. I'm now making it 127. Actually, let's make it 137. Okay? check out the value of local var after. Okay, because local var is 24 here, right? Remember, line by line until blah, blah, blah. Okay, check this out. Ah, goodness gracious. Building, not newing. Check it out. Look at that. Let's go. Let's go. Whoops. So you guys, check it out. See? Because this pointer is directly linked to local variable here, we could actually reassign the value of local var. So, right? That's why constness is, when the topic of constness and consting is talked about, right? This is kind of a good example of how variables and values could be changed, right? When you're running code in that, maybe just hypothetically you change the value of p local, which affected the initial value of local. Let me just call it local var, because that's kind of driving me crazy. Okay. Apply all. Let's just kind of, oops, I should close this. I'm going to build it and rerun it. Okay. Local var. Okay. Oh, I should have renamed it. Did it change it there? No, it didn't. It doesn't change it here, right? Local var. It won't change it there. It never will, right? Because that's a string literal. It only, when you do that, you can actually go right click, rename, and then I could change the name and it'll affect all of the variables. It's just one spot rename. It's nice. I like it. But it won't change your string literals, okay? So be aware of that. That you have to update. Okay, running, right? So you can see, right? This pointer can also affect the value stored right directly at local var. Okay, that's the point I wanted to make. So take note of that, right? When programs running, variables and values can be, that's the reason why we do all this, guys and gals, right? To change values, to do calculations, to output things, to make the magic happen. I'm going to leave it at that. That is it, guys and gals. Remember to delete your newing up memory. Always delete your newing up memory. Okay, you don't have to worry about it with this type because we're just making it equal to a memory address, which is technically stacked memory still, right? All right, even though this is a pointer, right? We're not using delete because it's a pointer. We're using delete because it's newing up. All right, point made. Point taken. You guys are all awesome. Every single one of you beautiful, intelligent people. Thank you for supporting, following me along, checking out the series, watching the video. Johnny with Bologna&Weiners coding. Much love, every single one of you. Also want to quickly shout out to White and Hood Rich. Much love, brother. Thank you for showing up and being awesome, dropping the W. My man, let's go. I appreciate you. That's it. I'm going to stop, okay? Heartstrings are being pulled. I love it. I love it when you guys show up. You guys are awesome. I'll see you guys in the next live stream video. Not live, not live. Hope you're having an awesome, have an awesome rest of your day, evening, noon, night. Whoever you are, wherever you are. Johnny with Bologna&Weiners coding. I'll see you guys in the next video. Take care for now and peace out. Peace.
Maybe I don't understand this.